Hello, hello! I'm going to be teaching you two calculus short answer problems. I hope you learn. The first one is 1991 BC1. So, the information we are given. Particle moves on the x-axis so that its velocity at any time t is greater than or equal to 0 is given by v of t equals 12t squared minus 36t plus 15. At t equals 1, the particle is at the origin. Don't forget that last part, it will be important later. So, the first part of our problem says, A. Find the position x of t, or s of t, either one, of the particle at any time t is greater than or equal to 0. Well, luckily for you, I have done the solution for you. So, the equation asks for the position, which is s of t. Now, how do you find position? You take the integral of the velocity equation, which was given to us in the original information. So, integral of 12t squared minus 36t plus 15 is, ta-da! S of t equals 4t cubed minus 18t squared plus 15t plus c. Now why is that c there? Well, we don't have any limits on our integral, so we have to find what the constant is. How do we do this? Well, A says at any time t is greater than or equal to 0. So we have to set the position equal to 0 to find c. Set it equal to 0 and plug in 1, which is from our original information that I said was important. 0 equals x of 1, and you plug in 1 as t. 4 minus 18 plus 15 plus c. And if you do all that math, you get x equals, equals negative 1. Which means your final position is s of t equals 4t cubed minus 18t squared plus 15t minus 1. So the next part of our problem says, B. Find all values of t for which the particle is at rest. Well, to find where the particle is at rest, you have to set the velocity equal to 0 because it is not moving. So, 0 equals v of t, and v of t is given to us in the original information is 12t squared minus 36t plus 15. So, set this equal to 0, and the easiest way to do this is take out a 3 and then factor it. So, you have 2t minus 1 times 2t minus 5. And then, you have to set each of these equal to 0. 2t minus 1 equals 0, so t is a half, and 2t minus 5 equals 0, so t is 5 halves. And these are where the particle is at rest. Okay, C says, find the maximum velocity of the particle for t between 0 and 2. To find the maximum velocity, we have to set dv dt, which is the derivative of the velocity, equal to 0, and use that point, 0 and 2, to find which one is the max. So our original equation was v of t equals 12t squared minus 36t plus 15. Find dv dt, which is 24t minus 36, and you set this equal to 0 to get t equals 3 halves. So I use these three numbers. 0, which is the smallest limit that we have, 3 halves, which is what we just found using dv dt equals 0, and 2, which is our maximum limit. Plug all of these into the velocity equation to find the maximum velocity. V of 0 is 15, v of 3 halves is negative 12, v of 2 is negative 9. The maximum of those numbers is 15. The last part of this problem is D. Find the total distance traveled by the particle from t equals 0 to t equals 2. Now, the problem with this total distance problem is, if you remember from an earlier part B, we found where the particle is at rest. Now, if the particle is at rest, that means it could be changing direction. So, we found the particle is changing direction at t equals a half and t equals 5 halves. We don't have to worry about the 5 halves because it's greater than 2, but we do have to worry about the 1 half because it's in between our limits 0 and 2. So we would have to split this total distance into two parts. So we would have to do this. The integral from 0 to a half v of t dt minus the integral from 1 half to 2 v of t dt. Now the integral of vt is s of t, which is position, which is what we need to find the total distance. So once we took the antiderivative, we have s of a half minus s of 0 minus s of 2 minus s of 1 half. So, in case you've forgotten the position formula, which we found in an earlier problem, S of t equals 4t cubed minus 18t squared plus 15t minus 1. We would plug in the 1/2, 0, 2, and 1/2, and we get these numbers. 5/2 minus -1 minus -11 minus 5/2. I have done the math for you, and it is 17, which is the total distance traveled. Our second problem is 1997 AB4. Let f be the function given by f of x equals x cubed minus 6x squared plus p, where p is an arbitrary constant. An arbitrary constant is really just a regular number. There's nothing special about it. A says, write an expression for f prime of x and use it to find the relative maximum and minimum values of f in terms of p. Show the analysis that leads to your conclusion. This just means we have to show our work. So the first part of the problem says we have to find the first derivative and set it equal to 0 to find our maxes and mins. So the original equation is f of x equals x cubed minus 6x squared plus p. So the first derivative would be 3x squared minus 12x, and you would set this equal to 0. You'd have to factor this out, and you would get 3x and x minus 4. If you set both of these equal to 0, you get x equals 0 and x equals 4. Now, quick review. A max means the sign of the number would change from positive to negative, and a minimum means the sign would change from negative to a positive. There are two ways to prove this. The first way is more just for your own understanding. It says f prime of x changes signs from positive to negative at x equals 0. This means you would plug in -1 and 1 and see that the sign changes from a positive to a negative. The second part says f prime of x changes signs from a negative to a positive at x equals 4. So you could plug in the numbers 2 and 5, and you would find that the sign changes from negative to positive. But this doesn't really answer the question and doesn't put it in terms of p. So the best way to do this would be to find the second derivative. Now the second derivative, if it is negative, then it would be concave down, and so it would be a maximum. If it is positive, it would be concave up and a minimum. The second derivative is 6x minus 12. And if we plug in these numbers 0 and 4, f double prime of 0 is negative 12, and f double prime of 4 is 12. So that means there will be a relative maximum at x equals 0, and a relative minimum at x equals 4. Now the problem does say to write it in terms of p. So we will plug in 0 and 4 into our original f equation, which means f of 0 is p, and f of 4 is p minus 32. The second part of our problem says, b, for what values of the constant p does f have 3 distinct roots? Well, in part A that we just finished, we found that f of 0 equals p, and f of 4 equals p minus 32. Now, since f of 0 equals p is a maximum, that would have to be greater than 0. And since f of 4 equals p minus 32 is a minimum, it would have to be less than 0, as shown here. Now, if you solve that, you would see that p is greater than 0, but less than 32. And that shows your 3 distinct real roots. The last part of this question is C. Find the value of p such that the average value of f over the closed interval from -1 to 2 is 1. So remember, with average value, there is a formula that we can use, and then we will use -1 as a and 2 as b. The formula is this. 1 over b minus a, the integral from a to b, f of x dx. Now, it does give us the interval, so we would use the -1 and 2. -1 would be a, and 2 would be b. So if we plug it in, as you see here, we would have 1 over 2 minus -1, integral from -1 to 2. The f of x was given to us in the original information, x cubed minus 6x squared plus p. And don't forget your dx, and we're setting it equal to 1. So I have done the antiderivative for you, and it is this. 1/3 times 1/4 x to the 4th minus 2x cubed plus p times x, evaluated from -1 to 2. And we're finding where this is 1. So simplify it and plug in the -1 and 2. You have 1/3 times 16 over 4, which is 4, minus 16 plus 2p minus 1/4 plus 2 minus p. And this is also getting equal to 1. One more time simplified. 1/3 times 3p minus 57/4 equal to 1. And last step, p equals 23 over 4, which is 5.75, and that gives you your average value.